Alright, today we're going to be doing a lot of organic chemistry ranking. And the first problem is rank by nucleophilicity. And we have these 5 organic molecules, and we're going to rank them from 1 to 5, with 1 being the strongest nucleophile and with 5 being the worst nucleophile. The first thing I would do is look at all these NAs. That shows it's positive on here, 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 and here. But what does that tell us? That tells us the other ion next to it is going to be negative. And as you can see, this one here is an alcohol because of the OH group. That makes it not an ion. Now let's look at the rest of these here. The next thing you want to look at is the negative ion. And as you can see, you have an oxygen, 2 oxygens, a nitrogen, and a phosphorus. Out of all these 4, phosphorus is the largest and the least electronegative, which by far makes it the best nucleophile out of all of these. The next thing I want to look at is this one right here. This one is a tert butyl group right here. To draw that out, that's going to look something like this. It's rather bulky because of how much mass it has, which will cause it to hinder its nucleophile ability, which would put this actually in last place right off the bat. Now we know first place and last place. Next, we have to go through these 3 right here. This might be a little more difficult, but if you know what you're doing, it will be quite easy. The first thing I want to do is look at this one here. If I were to actually draw out the molecule, I know it's going to look something like this. The next thing you should notice is this has the ability to resonate. And what resonance shows us is that this has a very stable conjugate base. The more resonant the structures, the more stable. And the more stable the conjugate base, the better of an acid it is. Now, in nucleophilicity, you actually want it to be a better base because all strong bases are strong nucleophiles, which would actually put this second to last. Now you have to look at this one, oxygen versus nitrogen. Both have a negative on their most nucleophilic atom, so those are generally stronger than anything with resonance. Next thing you want to look at is how their size and how electrophilic both of these are. The size is actually very close. They're actually right next to each other on the periodic table. You have oxygen on the right and nitrogen right next to it. But because oxygen is closer to fluorine on the periodic table, it actually makes it more electronegative, which would cause nitrogen to make it a better nucleophile. Now we're going to rank by Sn2 reactivity between these 5 molecules. For Sn2 reactivity, you want to look at 2 main factors. One, what is the leaving group, and what degree is the leaving group? As in, is it first degree, second degree, third degree? Is it benzylic? Is it allylic? Is it vinyl? Or is it phenyl? There are no double bonds or triple bonds here, so we're only going to see whether it's first, second, or third degree. So that's what we're going to do. We're going to label each of these by looking at the carbon it's on and the adjacent carbons. For this one here, this is the carbon that you're going to look at, and these are the ones around it. There's only 2 which make this second degree. And again here, this is your carbon. There's only 1 adjacent, first degree. Again, this one, first degree. And for here, you have second degree. And last one here, we have 1, 2, 3, third degree. Now, for Sn2 reactivity, you want it to be the least sterically hindered as possible. And the one with the most steric hindrance, in fact, is the third degree, which would put this one in last place. Now, next one you want to look at is these 2. One, the first degree and first degree. Now, these are pretty much identical, but the only difference is this is a bromine and this is an iodine. Now, out of these 2, you kind of have to know which is the better leaving group. And between these, iodine is actually the better leaving group because it is much larger than bromine, which would put this in second place. Now you have to look at chlorine and bromine. Same thing over here. Which one's a better leaving group? Now this one you kind of have to remember, but it's very simple. It would be bromine because of the same reason. Size and electronegativity. It's a better leaving group, which would put this in fourth place. And that is our order 4, 2, 1, 3, 5. Now we're going to rank by stability of the radical. And it's very simple. All you have to look at is the position of the carbon the radical is on, and then look at the ranking order. So benzylic would be adjacent to a benzene ring. Allylic is adjacent to a double bond. Tertiary is adjacent to 3 carbons. Secondary is 2. Primary is 1. Methyl is when you're looking at it on the methyl carbon. There's only 1 carbon available. There's nothing next to it. Vinyl is when it's when it's on the double bond, and phenyl is when you're on the benzene ring. So the order goes from here all the way down. Now let's label our organic structures. First one here, as you can see, this is the carbon, and next to it we have 2 carbons, so it's second degree, but this one right here has a double bond, which would make it second degree allylic. This one here, this carbon, is connected to these 2. But you can also see the carbon is actually on the double bond, which would make this second degree vinyl. And for this one here, again, basically the same as the first one, second degree allylic. Now we look at this one here. It's all the way up here. Now you're probably thinking, well, there's the double bond here. Well, actually the double bond is too far away. It's not adjacent to it anymore. Adjacent would mean that it's next to it. It is not next to it. That's why it would make this one simply first degree. And for this one here, this is the carbon we're looking at. And next to it, we have 3 bonds. So now we have third degree here. Now, between all of those, you can, if you can figure out what it is, whether it's second degree, first degree, tertiary, benzylic, allylic, it's easier at that point to actually rank it. So the number 1 would actually be this one here. Now you're probably thinking, what makes this different from this one? Well, this one is actually slightly more stable because it's inside of the ring, whereas this one is outside of the ring. So that's what makes this one second degree. Now, after that, let's just look at this one here. The vinyl is one of the worst ones, and none of these are worse than vinyl. None of these are vinyl, and none of these are phenyl, which would make this automatically in 5th place. Now, between first, this one would be slightly better than this one, because this is third degree, this is first degree.